review, which is when we were going over chapters 1 and 2. So a lot of this should be review for you. You work through similar ideas in your summer packet. So what I'm going to actually have you do is I will leave this is the blank set of problems, and I'm going to ask you to work through these and then come back, and then I'll show you the answers. So please push pause on the video right now, work through these problems, and then come back and check your answers. Here's some explanations. Maybe you still got the same answer, but maybe I did it a different way. So push pause now. Okay, as I go through the answers, the first thing I did here was I subtracted 33 and 45. I subtracted 64 and 78. Negative 12 minus a negative 14 is the same as adding a 14, so negative 12 plus 14 is 2. Over here, you can see I probably did more order of operations. I know exponents had to come before adding. I knew multiply had to come before adding. And I saw this minus a negative, which was turning that into a plus sign. So 3 cubed is 27. 3 to the third means 3 times 3 times 3. So 3 times 3 is 9, times 3 is 27. 8 times 5 is 40, and again the plus 5. And then I just added the first two terms, and I added the last two terms. Over here I knew multiplication and parentheses comes before subtraction, so I multiplied 8 and 7, then subtracted the 13. Over here I showed kind of two ways to do it. Multiply and divide is whatever comes first from left to right. So it isn't all multiplication before you do division, so be careful. That's a very common mistake. I showed a common way here. 54 divided by 3 is 18, and 18 times 2 is 36. But division can always be written as a multiplication problem. It's called the definition of division. So taking a number and dividing it by, say, 3 is the same as multiplying it by 1/3. And sometimes when you rewrite it that way, like I did here, this and this mean exactly the same thing. And sometimes using that definition of division takes out that, wait, what do I do first? Do I multiply or divide? You're multiplying by 1/3, and that way you're not trying to say, 54 divided by 6 or something. And you see that gets to be the same answer. Over here, I found the numerator and denominator. Then I divided and subtracted 2. Over here, I have to work that entire parenthesis out first. So I got that down to 10. 32 is coming from 2 to the 5th, which is 2 times 2 times 2 times 2 times 2. Then I multiplied the 3 and the 10, and then subtracted the 53 and the 30. All right, on this one, I'm going to ask you to do the same thing. I'm going to ask you to push pause so you can read the problems, work through them the best you can, and then come back for the answers. Okay, absolute value means the distance a number is from 4. So it's anytime you see absolute value, you can kind of reword it to yourself as, okay, how far is negative 4 from 0? I don't know if I said that right the first time. How far a number is from 0. So negative 4 is a distance of 4 from 0. Always positive because distance is always positive. Over here, the absolute value of 18 plus 4. Okay, what is 18 and 4 together? 22. How far is 22 from 0? It's 22 units away from 0. Over here, it's practicing plugging numbers into expressions. You can see I plugged in the 3 and the 5 appropriately for the x and the y. I did my multiplication here. 3 times 5 gave me the 15. And just to talk to you a bit, you need to be flexible with numbers. They're finding that people who work well with math are flexible. So when I look at this, I see 15 sevenths. Now, some of you are going to desperately try to change that to a decimal. What I look at is I say 15 sevenths, and I think, wow, that to me is not a number that's easily turned into a decimal. It's probably going to be, I know it's 2 point something, but it sounds messy. So I'm going to leave that as a fraction because that seems easier to me than getting a really long, non-exact decimal. I did 3 minus 5, which gave me the negative 2, and said, okay, negative 2 plus 15 sevenths. Notice I never changed it to an improper. You don't have to. I changed I said, okay, negative 2 is the same as negative 14 sevenths, And this looks a lot, I said sevens because I wanted it to match here. Negative 14 sevenths plus 15 sevenths gives me 1/7. Now in the next problem, again, I plugged in the 1.6 where I substituted it in for y. And here I have another, I changed the division into a fraction. Divide and fraction they're the same thing. It's not two different things. When I looked here and I saw 1.6 divided by 8, what I recognized is, well, I know 16 divided by 8, so this is really close to that. I'm going to change this to a decimal, which is what I did here, because it was easier for me. I multiplied the 3 and the 1.6. 4.8 take away 5 leaves me with negative 0.2. Negative 0.2 plus 0.2 is a 0. Okay. All right, one last time, I'm going to ask you to push pause on this screen, work through these the best you can, and then I will come back and give you the answers. All right, over here, again, I plugged in negative 3 in for the x's. I substituted, I shouldn't say plugged in, I substituted. Negative 3, when you plug it in to x, is in parentheses. You're substituting it directly in for x. It should be in parentheses. That makes a difference. Negative 3 squared when it's in parentheses is 9. I did 8 times negative 3. That's where the negative 24 came from. There's a couple different ways you could have represented that. Some of you may have seen it turn into the plus 24 right away. And then I added everything to get the 43. Over here in these two equations, I just want to talk to you a little bit about noticing what's happening. I get people that look at this and immediately multiply both sides by 3/4 or something because, well, it has a fraction. You must multiply by the reciprocal. You can. You definitely can. I'm just not sure that it's really going to help you very much if you try to do that. You'll get the same answer. It's just going to, let's say, take you on a longer road. So what I looked at here is, okay, here's negative 4/3. It's on the same side as the x. Is it being multiplied with the x? No, it's not. So the opposite of negative 4/3 is positive 4/3. So I added that to both sides. So negative 1/3 plus 4/3 is 3/3, which is the same as 1. And now I remember to bring that negative down. So I still have a negative x on this side. So to make that positive, I multiply both sides by negative 1. So x equals negative 1. And please remember, you can check these. If I plug negative 1 in for x, I'd have negative 4/3 plus a whole, which is 3/3. And you can always check. That's the beauty of equations. All right, over here, when I see that fraction with the x, now it's being multiplied with x. So I'm going to need to do, a multiply divide step to move it. So first thing I did was add a 9 to both sides. That got me to here. And then I multiplied by the reciprocal. Multiplying by the reciprocal is the same as dividing by a fraction. You should have learned about that in your earlier grades. So I multiplied both sides by negative 4/1. Negative 4/1 times negative 1/4 gives me the positive 1x I was looking for and gives the right side negative 1/4. Down here is an important piece. These representations for squaring are important. When I say 3 squared, most of you know that's 3 times 3, so it's 9. When it's written like this without parentheses, it means square the 3 or square whatever number that is. Make your result negative. Apply the negative after you square it. It's kind of like multiplying by negative 1. So you're going to square it, then multiply it by negative 1. So notice here, when there's no parentheses, that is actually equal to a negative 9. Now, when it is in parentheses, kind of like we had up here, that means take the entire group in the parentheses and multiply it by itself. So negative 3 times negative 3 equals 9. And you may want to star that. This is an area where a lot of people start to struggle. And I have those here. In this one, the ones I want to just note here, and I don't believe I did the answers. I did. For this one, again, push pause, work through it, come back. And over here, you'll see when I plugged in 8, I got a 0 on the top. So if I have 0 cookies and I have to divide them among 12 people, how many cookies would each person get? They get 0. Now over here, the 0 occurred in the denominator. So if you have 8 cookies, here are 8 cookies, I want you to divide them among no one. Well, even when you hear me say that, you're like, wait, what? You want me to? I don't even understand. That doesn't even make sense. Um, so that is undefined. You cannot divide anything by 0. So you really need to be careful where that 0 is happening. Are you dividing by 0? That is a very basic math no-no and really leads to some important ideas in mathematics. Over here, kind of that idea again. I want you to look where it's easier to go to decimal and when's it easier to go to fraction. 7/10 I look at and say, oh, that's easy. So I change that to 0.7. 2.5 over 5. I said, well, I know what 25 over 5 is, so that seems pretty easy. And 30% to a decimal. So I left all the answers in decimal form, or all the simplification. So I got 0.9. Now over here, what happened is I went 3.75, that's not bad. I could go either way. 5/12, that it sounds like a pretty difficult decimal, so I left that as 5/12, changed everything else to a fraction. At this step right here where you see 15/4, that's me taking the mixed number, changing it to an improper. And again, the 5/12. Then I got a common denominator. That's what happened here. I added the numerators. That's what happened here. And I simplified. And I believe that is the end.